Welcome to AP Calculus. Today's notes are 2-3, but I want to talk about where we are in our unit before we begin. So 2-3 is right here, the general and power chain rule. We're actually taking derivatives of houses today, and then we're taking derivatives of houses all the way down here to 2-6, then harder rules. Ending with product rule and quotient rule. You will learn to love the product rule, maybe hate the quotient rule, although it has the coolest rhyme ever. But yeah, so there we are. Let's go ahead and begin with 2-3. Today's date is Monday, September 16th, 2019. What's up, Sego?
I turned 17. Hooray.
Oh, congrats.
Yeah, it was yesterday.
Happy birthday. We're going to be singing to you this Thursday, I imagine.
Yeah.
So does that mean Ben's officially like the youngest? He's the only one who's 16.
I'm the oldest. It's kind of sad.
I can look up the stats and see how young, because I'm pretty sure there's quite a few people that are juniors that are older than Ben.
Yeah.
Oh, yeah. Anna, Lorena, Jaden.
Anna and Lorena are older than
No,
me.
actually, true.
Aurelia.
By 2 weeks. Wow.
Caroline.
And they were born a week early.
Dang, yeah, that's a lot. All right, who can read our objective for today?
Use the chain rule of the general and power houses.
Yeah, so we're doing general house, powerhouse. Tomorrow we're also doing powerhouse, but harder. So today's kind of like the intro powerhouse. But we're just learning the chain rule over and over and over again. When you go to college and you say chain rule, people will know what you're talking about. If you say, what house are you in powerhouse? They will not know what you're talking about. Chain rule is official. Houses are something that Mr. Wynn uses to make sense of these problems. So before I begin, let's talk about how to say derivative different ways. So first of all, who can say d dx of u the correct way? How do we say that?
The derivative of x is
It's the derivative of something with respect to something.
The derivative of x. Of u in respect to x. There you go.
Yeah, so who can say the next one?
the derivative of u with respect of x.
V.
Oh.
And then-
Derivative of v with respect
And then
to x.
Sego, do this one.
The derivative of x with respect to x.
Yes, exactly. So we know how to pronounce those from before, but there's another way that I can write these, and I want them all to be written down right now. So this one can be now rewritten as du dx. It is pronounced the same exact way, the derivative of u with respect to x. It's just written differently. And it makes sense too, because if I treat this as a fraction, that's u over 1, u comes to the top, 1 goes to the bottom.
You always have
it makes
the x
sense.
and dx thing in the bottom? Like the x, like would always be two respective.
For now, yes. Later, no. Especially in AB, which is the first half of, or the first part of calculus, almost all of it is going to be dx, but even in AB, you do have something like D capital B, like it does change. For this whole unit, I'm pretty sure it stays dx, don't worry about it. And then obviously we can rewrite these differently as well, write them down. This is going to be what? Yeah, dv dx, pronounced the same way, the derivative of v with respect to x, and the derivative of x with respect to x, which is exactly 1. We'll come back down here. I mean, dx over dx, anything over itself is 1. So I think 2 lessons ago, when we did 2-1, I told you the derivative of a linear is the coefficient. So this is the derivative of 1x, and Gio's like, oh, that's 1. That is correct, but the rationale behind it is it's the same thing over the same thing. Dx over dx is indeed just 1. Bless you, bless you. Bless you. All right, so far so good? What we can also write is that these things are equal to their prime. So this is considered u prime, or this is considered v prime, or x prime. X prime, of course, is equal to 1. And we need to think about what they mean in terms of a context of maybe a word problem. So in a word problem, u prime, or du dx, the derivative of u with respect to x, this is, and I need all of us to write them out, this is how fast u, whatever that represents, it might be meters, it might be feet, I don't know, whatever, u is changing. And if I want to be very technical, I'd say with respect to x, but we've said it so many times now that I guess I'll just write it once and be done with it. How fast u is changing with respect to x. All right, so how would I say v prime? What would that be in a word problem? It's the same words.
How fast v is changing with respect of x.
And there it is. So this is going to be how fast v is changing.
What happens if like you don't got respect for x?
If you got no respect,
Yeah.
then actually come over and beat you up and then get that respect.
I
Yeah, maybe. I don't know.
Maybe a little bit mixed in there. I don't know. And then obviously this is how fast x is changing with respect to x. I'm not even going to write that. But you should be knowing that these are talking about rates. How fast things are going. How fast is your car going? How fast are you running? It's talking about speed generally. How fast things are changing. And it might be how fast speed is changing. How fast that speed is changing means how quickly I'm stepping on the pedal for your car. It might not just be how fast a distance is changing. It might be how fast a velocity is changing. You guys are all in physics right now, right?
I just press it and just go.
Us three are shooting.
Okay, so Arrow, have you ever taken physics?
No.
Okay, so these will not be useful to you until you take physics, but
Until it. What? I'm not gonna say.
I will-
It's our last
I will
day.
continue
All
to
our
use my
last
metaphors.
years.
There's no physics.
let's talk about the chain rule. The chain rule is basically this entire unit aside from product rule and quotient rule at the very end. Chain rule, chain rule, chain rule. It's the most important rule this unit. And I would say it's one of the most important rules in all of the first half of calculus. It's used extensively. So it is saying if I have a function g of x inside a different function and I'm trying to take the derivative, what is going to happen? Well, we'll talk about that in a sec. But generally we need to start identifying the outer and the inner, again, just like we did in 2-2. So think of f as the house. F is the house. And think of the g of x as the inner. That's really what I'm saying here. If I have a house on the outside, the inner on the inside, what is going to happen when I take the derivative? And should I tell you now? Yeah, I might as well just tell us now. What is this rule? And I'm going to do it in red. It is important. So the way that I write this rule is formally in the textbook, this is what it looks like. It's going to be f prime of g of x, and I'm halfway done. But first of all, it's the derivative of the house. Leave the inner the same. The inner is still there. It has not changed at all. It's the same inner. Same inner.
I have an extra parenthesis. Or no, that's supposed to be there.
But I have taken the derivative of the house. So notice that it's f prime instead of f. It's house, the derivative of house. So derivative, how do I abbreviate derivative? Derivative of the house. So derivative of the house with the same inner, but that is now going to be multiplied by g prime of x. Who can interpret that?
This is important. Times the derivative of the
Yeah, derivative of inner. I'm going to write this derivative of inner. So notice that the inner stays the same while being encased in the house. The house takes the damage first. It takes the derivative, and then I take the derivative of the inner and just multiply it by whatever I started with. Okay, it's kind of not making sense so far, but I will hopefully make sense of this by the end of this lesson. All right, so if the outer is f of something, we used to put u in here, right? So you can put u in here if you want. And the inner is something with x, I guess. Or v, if we're doing inner, I can put v here. Let's just say that we don't know what the inner or inner is. So we're leaving those blank, essentially. If I'm taking the derivative of the outer right here, the derivative of the house, I'm going to pronounce this as d-outer or doubter. The derivative of the outer is the derivative of the house, that's doubter. Whenever you hear the word doubter from here on out, that's the derivative of the outer, the derivative of the house that we're talking about.
What about if somebody says, I'm a doubter?
Well, from now on, we can talk about forgetting dinner. So, I always forget dinner.
Yes.
Very
Don't,
important.
everyone always forgets their dinner. They starve. It's bad.
Yeah.
But doubter, what is the derivative of f?
Oh, it's dinner.
That's
Dinner.
fine.
There it is. Say it again louder.
Which one of us got it?
Arrow, you got it.
Oh, F prime.
If the outer is f, doubter is f prime of whatever our inner was.
So guess what dinner is?
What is dinner?
G prime.
It is g prime. G prime of whatever we started with. And what's, if I have my inner as x, what's my dinner then?
I love these words.
It's yeah.
What is x prime?
1.
1. We just wrote that up here. X prime is 1. So we've practiced finding what the outer, inner, and sometimes even inner are. Now what I'm expecting you to do is take the derivative of each of them. So far so good?
Derivative of the derivative?
It's not the derivative of the derivative. That would be the second derivative. We're not going to hit that in this unit. We're just doing the inner and then taking the derivative of that, the dinner. It's not the dinner. It's the dinner. All right, but
Can we get to high, low, the like rhyme about
low-d high over high-d low? Yeah. So there's a lot of cute catchphrases, but okay, are we all clear? Give me a fist of 5. Doubter, dinner, and dinner inner. Do we know what those are? So if I talk about them 3 months from now and I say dinner, you're like, oh, derivative of inner. You're good on that, right? All right, you're going to have these memorized. Geo Hood. All right, so let's try an example. Before we even take the derivative, let's just analyze it. So I'm going to come down here, analyze it, and then I'm going to come back here and actually write out what the answer is. So first of all, what house are we in? You have 2 choices because look at the notes. We're talking about general house and power house. This is the general house because we have f of something. Whenever you have f or g of h or some letter of something, we're talking about the general house.
Wait, repeat that.
So if you have f of something, h of something, g of something, some weird letter with an inner, you're talking about the general house. It's pretty easy to distinguish because this is like a bunch of gibberish math with no weird letters. This has a weird letter, f. That means we're in general house.
That one would be powerhouse.
This other one's going to be a powerhouse. Why is this one going to be a powerhouse, Gio? Because it doesn't have any letters and it has this power of 3. Exactly. All right, so we know that we're in the general house. What's the outer then of this general house? 2f of something. We'll leave it blank. You can put u in here if you really want to. I'm going to leave it blank. 2f of something. What's the inner? What goes inside the parentheses? There it is, 3x. This is all review. You know how to find the outer. You know how to find the inner. Now today, you should be able to find doubter and dinner. What is doubter?
2f prime.
2f prime of whatever. Exactly. Good job, Gio. What about dinner?
That would be
3. You just take the coefficient, right?
yeah.
3. Okay, we're not done. We have analyzed this problem. Now we need to write it out using this formula in red because it's important. That's why it's in red. So using this formula, I now need to say I do the derivative of the outer, so doubter times dinner. In fact, can we come up here and write this even more important? This is really just doubter, outer, times inner.
Did you come up with these words, or are they like commonly used in math? Like,
They are not commonly
If I
used.
walk up to my math class and be like, "This is dinner," but like,
They will-
I'm insane.
They will think you're insane, yes.
Okay.
Doubter times dinner. That's going to be a flashcard. What is the derivative of outer and inner? It's doubter times dinner. Know that it's always doubter times dinner. Doubter times dinner. Doubter times dinner. Don't forget dinner. You'll always do doubter and you'll forget dinner.
Yeah.
It's doubter times dinner.
I just snack instead.
yes, square.
All right, so we're going to do doubter times dinner here. Here we go. This is now equal to. Well, what is doubter? What is doubter?
It's 2f of prime.
2f prime of something. That something now needs to be something.
Of 3.
Of 3x because 3x was the inner. All right, now I did doubter. I can't forget dinner. What is dinner?
3.
Done. Well, I mean, you could simplify this, of course, and you should in my class, but that's basically it. 3 times 2 is 6, so this now simplifies down to,
F prime of 3x.
there it is, 6f prime of 3x. There's your final answer. You can box it. It's doubter times dinner, over and over. Doubter times dinner. Don't forget dinner. Don't forget dinner. Doubter times dinner. Doubter times dinner. Repeat after me. Doubter times dinner. Again. Again. Don't forget it. Doubter times dinner. All right, we're on to example number 2. What house are we in? Non-Geo. Geo did this already, but what house are we in? We're in Powerhouse. Why are we in Powerhouse, Dego?
Because there's a power.
Because there's a power. There's an exponent. Exactly. That's easy. All right, so someone shout out. What is the outer?
2.
2 of something to the power of 3. There's the outer. All right, I need the inner. 4x plus 1. I'll pause. So far, so good. We've identified the house. We know what the outer is. We know what the inner is. I need to find doubter.
2 prime of something to the power of 3.
Ooh, so you can actually do the prime now. You have to remember all the way back to 2-1. How do you do the power rule?
6 of something to the power of 2.
Exactly. This comes down and multiplies. 3 times 2 is 6. So this doubter is going to be 6 in parentheses, and then this isn't a 3 anymore. It's a 2. You go down a power. So far, so good? This is just the power rule.
It's not moving closer to 0.
I mean, it is getting closer to 0 if you look at it graphically.
But
But
like if it's negative.
oh, in terms of the number, yes, it's just going down one.
Okay.
Exactly. All right, and then dinner. What is dinner?
5.
Close.
4.
It's 4.
Oh my god.
It's 4 plus 0 to be exact. 4 plus 0 because the derivative of 4x is just the coefficient 4, and the derivative of 1 is 0. The derivative of a number, of a constant, is just 0. All right, Gio, re-explain it back to me. Why is it 4?
Because you're taking what's in front of the coefficient.
Exactly. The number in front of the coefficient. And if there was a 4x squared, then that gets a little bit harder. But for now, I'm going to make sure that you're... Oh, that's not true. For some of your homeworks, you're going to have 4x squared. So I am going to trip you up a little bit. But generally, these should be nice and easy powerhouses.
All right.
Wouldn't it be 8x then? If it was 4x squared?
Let's come back here and actually answer this. This should be what two words multiplied together?
Dinner times doubter. Doubter times dinner.
Doubter
Yes.
times dinner. Dinner's always second. Well, it doesn't matter because it's
Yeah,
multiplicative,
it's
commutative property, all that.
But it makes more
So
sense
the answer is
to
going
put
to be
dinner
6,
after.
6 to the inner
Yeah, so 6 times something squared. What is that something in here?
4x plus 1 times the dinner, which is 4.
Done.
You make us do dinner inner even though there's no.
So yeah, last year everyone asked me like, well, how do you know when you have an inner and when you don't? For now,
Double
the-
parentheses.
well, that's not necessarily true. You actually always have an inner, because as long as you have an outer and an inner, you always have an inner. The inner is just x.
So then,
What is
So it's a 1, but when it's not a 1.
oh, because it's multiplied times once and then it just doesn't matter.
exactly? So I'm not going to confuse you. Ignore
If
everything.
Has has like an X in it, then you have to do.
But for now, don't worry about inners when they happen. For now, just work finding the houses, work finding the outer and inner, work finding doubter and dinner, then multiply doubter and dinner, and simplify, which we have not done yet. So we will simplify. Stego, can you do this for us?
Maybe. Do you just multiply 4 and 6?
Yeah. 24, 4x plus 1 to the power of 2. Done. Box it.
Can you simplify the power or no?
It's a
I'll leave it just to the power of 2. I mean, you could multiply it out using a binomial expansion, but let's leave it like that. It's nice and easy.
Okay.
That's it. That's all I have for you guys. It does get a little bit harder because some of the inners aren't linear. Some of them are quadratic and even bigger than that. But generally speaking, that is all you need to know. Questions?
Yes.
Oh, go for it. Yep. Okay, so don't do the summaries now. Wait for tonight.
Do you have